Question 1 says, a region S is enclosed in the first quadrant by the following. The curve y equals e to the negative x squared, the curve y equals 1 minus cosine x, and the y-axis. Compute the area of the region S. And we have a nice little graph over here to show us the region that we're finding the area of. It's always nice if you have a graph like this because when you're doing these problems, you really want to think about the integral top minus bottom. So if you look over here, the top function is the e to the negative x squared function, and then the bottom function is the 1 minus cosine x. So when we go to do our integral, it's going to be e to the negative x squared minus 1 minus cosine x. Be sure to put the second one in parentheses like this. Although we are going to be plugging it into our calculator, you have to make sure that this negative applies to every piece over here. All right, now the next thing we have to figure out are the limits of integration. Now, 0 is the first one. That's pretty easy to see. But it's not exactly obvious what's going on over here. It seems to be somewhere between 0.8 and 1.0. So what you're going to have to do is you're going to have to use a calculator to figure out what this limit, this upper limit, is going to be by finding their intersection points. So you want to graph both of these. Now I've already done this. If you graph both of these functions in your calculator and then you use the intersect feature to find out where they intersect, what you find out is that at least at this spot, they intersect at 0.94194. Which matches up with this graph, right? Somewhere in between 0.8 and 1, a little bit closer to 1. So that's what goes up here, 0.94194. Now all of this is going to get plugged into your calculator, and when you do that, you get 0.591. And that's our first answer. Part B says, if region S is rotated about the x-axis, calculate the volume of the resulting solid. Well, this is going to be a solid or revolution question, so that means you need to know the disk method, the washer method, or perhaps the shell method. So if we come over here, let's find the x-axis and draw a little arrow to indicate we are rotating it around there. And then let's go ahead and let's draw a rectangle bounded by the two functions here in the shaded region. We're going to call the width of this triangle here delta x. And there's two things that we're going to find here. We're going to figure out the distance from the axis of rotation to the furthest point of the rectangle. That's capital R. And the distance from the axis of rotation to the shortest point, or the closest point, which we'll use as little r. So that means we need to find big R and little r. Well, in order to find big R, can you see that we're starting at the axis of revolution here, and we're going all the way up to this top function here, the e to the negative x squared. That is our r. Our bottom function starts at the axis of revolution and goes to this function here, the 1 minus cosine x function. Now, since we have two r's here, capital R and little r, that means we're going to be using the washer method, which looks like this. So all we have to do is take everything that we know and plug it into here. So let's see what this turns into. Now, what I recommend doing is leaving some blank spaces and putting the squared parts here like this, because sometimes it's really easy to just plug in r here, and maybe because there's already a squared here, you forget to square it, right? You have to take the whole thing and square it, even if it's already squared initially. Right? You could write e to the negative x squared and think, oh, well, okay, I'll go on to the next piece here without writing out this second squared part here. And then, of course, we have 1 minus cosine x over here. And then our limits of integration are going to be the same limits of integration as last time, which is why I left this here. It's going to go from 0 to 0.941. Let's see here, 94194. Okay, now you're going to plug this into your calculator. And when you plug it into your calculator, you get 1.746. So that is the volume of the resulting solid of revolution based on this problem. Part C says, suppose region S forms the base of a three-dimensional solid where each cross-section perpendicular to the x-axis is a square. Determine the volume of the solid. Well, okay, the very first thing I'm going to do is I'm going to draw this shape that they told us. It's going to be a square, so I'm going to do my best to draw a square. And the cross sections have to be perpendicular to the x-axis. So why don't we take a point here like this. This is going to be our cross section. I'm going to do my best to draw a three-dimensional square here. It's kind of hard to do. Oh, that's supposed to be a square there. So when you do these problems, we're looking at just a single slice of this entire piece here. We could have drawn this cross section anywhere, and everywhere we would have drawn the same shape, a square. Now, when you're doing problems like these where they talk about the specific shape, like square, it could be rectangle, it could be equilateral triangle or something, what you're going to end up doing is you're going to be finding the integral of the area of that shape. So, okay, how do we find the area of this shape here? Well, here's what we do. This little cross section, this line that I drew here, we're going to call that S. This is the side length of the square. What we need to do is come up with a formula that will give us the side length here. And you'll see why we need that side length in just a moment. But can you see that no matter where I drew this like square shape here, it's always bounded by the top function and the bottom function. In other words, what I'm saying is that you can find S by taking whatever the top function is, e to the negative x squared, and subtracting from that the bottom function, 1 minus cosine x. Don't forget to put the second piece in parentheses here. Okay, so why do we need an equation for this side here? Well, it's because we're trying to find the area of this rectangle, or actually of this square, excuse me. And the area of a square, if you know one of the sides, is just take that side and you square it. So that means that if we come up here and I take my A for area, because this is a square, I know that the side length squared is the area. This is the integral we're going to use right here. So we're going to have the integral from 0 to 0.94194. And then it's going to be S squared, like this. Put the parentheses, leave a blank space, and square it. Then come back and figure out what S is. Take this and plug it in. So let's see here. Did I give myself enough room? Just barely. There we go. That's better. This is what you're going to plug into your calculator. It's what you have to integrate. So once you do plug it into your calculator, you're going to get 0.461. And that is the answer. If you found this video helpful, you might consider checking out my website, which is linked in the description below. You'll be brought to Infinity Learning Academy, where you can find Cruising Through Calculus. At Cruising Through Calculus, we have over 100 videos and documents to help you get through your calculus class, including videos for each topic, practice problems, and full video solutions for those practice problems. I hope to see you there, and together we can cruise through calculus.